Okay, we'll move on to the next problem. The next problem is on the radial line method. We'll take up radial line method. Here it is a regular pentagonal pyramid. It's a pentagonal pyramid. So pyramid, we need to take up the radial line method. Okay, so a regular pentagonal pyramid of base side 35 mm and height 65 mm has its base on HP with a side of the base perpendicular to VP. So that is the condition to be satisfied while drawing the front view and the top view, that you are already familiar with the writing the front view and the top view with the given condition, which is as same as the projection of the solids. Then the pyramid is cut by a section plane which is perpendicular to VP and inclined at 30 degrees to HP. The cutting plane meets the axis of the pyramid at the point 30 mm below the vertex. Obtain the development of the remaining portion of the pyramid. That is the problem. So this is the top view and the front view, which is already written. It is a regular pentagonal pyramid of base side 35 mm. So this is 35 mm, 35 mm, and height 65 mm. It is already written 65 mm. Has its base on HP with the side of base is perpendicular to VP. This is the side of the base which is appearing perpendicular to VP. Okay. The pyramid is cut by a section plane which is perpendicular to VP, something like this, perpendicular to VP and inclined at 30 degrees to HP, 30 degrees to HP. This is the section plane. So 30 degrees to HP and perpendicular to VP, the pyramid has to chop off something like this with the help of section plane. The cutting plane meets the axis of the pyramid at a point 30 mm below the vertex. So this is the vertex, which is O dash vertex. Below the vertex 30 mm. 30 mm is the axis. So here you need to draw a 30 degree line from this particular point, which is 30 mm below the axis, below the vertex, because the section plane should meet the axis 30 mm below the vertex is the condition given. So from this you just draw a section plane which is 30 degrees to HP. This is 30 degree and the section plane should be thick at the end, should be thick at the end. Okay. Now only the remaining portion of the pyramid should be darkened. Before that, how to identify the axis center? You know the identification of the center by drawing the perpendicular bisector in the case of pentagon. In the case of hexagon, by drawing the diagonal, you can find the center. In the case of pentagon or in the case of triangle, you need to draw the median to identify the center. In the case of pentagon, you need to draw the perpendicular bisector to identify the center. So I have drawn perpendicular bisector to identify the center. After identification of the center, from the center I should draw lines which is darker to represent the lateral edges. These are all the lines which represent the lateral edges, and this is the base of the pyramid, pentagonal pyramid, base of the pentagonal pyramid. And I need to name this. I can start with this point or I can start with this point, that's your wish. So I will start with A, B, C, D and E. Now this is point A dash in bracket E dash, this is point D dash in bracket D dash, this is point C dash, and this is O1 dash which is in bracket this O dash. Okay, this you are familiar, and this is the retained portion. This is the retained portion. So this is the retained portion that is to be taken up for the development. Okay. So now after constructing this by taking the projector, after constructing the front view, you need to identify the true length. You need to identify the true length. What should be the true length of this? So after construction, you will get the true length as 71.5 You'll get the true length as 71.4. Now you need to keep in mind, in development each and every line should be in its true length. You should keep in mind always, in the case of development each and every line should be in its true length. Therefore, you should come back to the line concepts of lines. What the concepts of lines tells or teaches us, if a line appears parallel in one of the plane, you will get the true length of that in the other plane. That is what the concept of line. If a line appears parallel to xy line in one of the plane, you will get the true length of that in the other plane. Okay. So here, this is the vertex O and in bracket O1. So OC, just have a look at the edge OC. The OC is appearing parallel to xy line. So this is the xy line. So OC is appearing parallel to xy line. Therefore, you will get the true length of OC in the other view. Therefore, O dash C dash is the true length. O dash A is not the true length because OA is not parallel here. OE is not true length because OE is not parallel here. Only the lines which is parallel in one of the axis, one of the plane, you will get the true length in the other plane. Okay, so OC is appearing parallel here, therefore OC should be the true length. Therefore, you need to measure true length OC only. That will come up as 71.4. Now, since it is the radial line method, you can draw anywhere on the blank sheet. It is not restricted to write the development just beside the front view only, because we will be using radial lines. So you can draw it anywhere. So start writing from this point, draw a line randomly. Anywhere, just draw a line. Okay. Now with the help of this radius 71.4, take 71.4 in your compass, select this as center, 71.4, draw arc. So this should be, this radius should be 71.4. Draw arc. Okay. So what should be the end of the arc? Here it is not a cone. To find out the angle theta. Okay. Here it is a regular pentagon. And since pentagon has got 6 sides, 1, 2, 3, 4, 5. Sorry. Since pentagon has got 5 sides, AB, BC, CD, DE, EA. 5 sides. You can restrict this curve to 5 sides. Each side equal to 35, 35, 35, 35, 35, 35. So take 35 in your compass, select this as center, 35. Cut one side, again 35, again 35, again 35, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. This is where it should come. So I will just increase the dimension, sorry. From this point, take 35, cut here, again 35, cut, 35, cut, 35, you cut 1, 2, 3, 4, again 35. You will get the end. You just join that particular end. Again use thin lines here, join all the points here with the vertex, from the vertex. These represents the lateral edges or lateral surfaces of the pentagonal pyramid. 1, 2, 3, 4, 5. 5 lateral surfaces. This is A, B, C, D, E, again A. Now just have a look at this. This lateral edge OA is cut by the section plane at this point. So this is 1 dash. This lateral edge OB is cut by the section plane at this point. This is 2 dash. OC 3 dash. OD 4 dash. Okay. Then here one more point OE 5 dash. So here there are two lateral edges OA, OE, so 1 dash 5 dash, OB, OD 2 dash 4 dash, OC 3 dash. Okay. Now I already told you, in the case of a development, each and every line should be in its true length. Therefore, you need to extend all the points to the true length line. In the front view, we identified as OC is the true length. Therefore, just extend the point 1 dash to this particular point. This is the new 1 dash. New 1 dash. 2 dash to this particular point. This is the new 2 dash. Similarly, 3 dash is already on that particular line. 4 dash is this. And 5 dash is this. So you need to just extend 1 dash 5 dash to the true length line, 2 dash 4 dash to the true length line, because you need to measure the true length. So each and every point you need to extend to the true length. Okay. Now take the radiuses here, O dash to 1 dash on the true length line, O dash to 1 dash. You measure here, this is O, this is 1, this is O, cut, this is 1 dash. Similarly, B, OB means OB is the point 2, 2 is here, O dash to 2, measure O dash to 2, cut here, this is 2 dash. Similarly, OC is 3, OC 3, cut here, 3 dash. OD is this, you just transfer the height, OD, 4 dash, not this one, this, 4 dash. Similarly, OE, not this, it is the true length, okay, OE, that is O5, from here to here, this is 5 dash. Similarly, O1 dash, O1 dash, 1 dash. Now you need to join all the points, 1 dash to 2 dash, 2 dash to 3 dash, 3 dash to 4 dash, 4 dash to 5 dash, 5 dash to 1 dash, 1 dash to A, 1 dash to A, here also 1 dash to A, and since here it is the edges, okay, 5 edges, you need to join A to B with a straight line. You should not retain it as curve. B to C you should join with a straight line, C to D you should join with a straight line, D to E you should join with a straight line, E to A you should join with a straight line. Okay. Again, this is not completed yet. The retained portion, lateral edges 2 dash to B is the retained portion, 2 dash to B. Look at here, 2 dash to B is the retained portion. This is cut off portion. This portion is going to cut off. Okay. So only the retained portion should be darker. Similarly, C dash to 3 dash, similarly 4 dash to D and 5 dash to E. So this is the development of the said pentagonal prism. Thank you. ತಡಿ ಫನಲ್ ಬಂದು ಎರಡು ಮೂರು ನಾಲ್ಕು ಇದು ಐದನೇದು. A hexagonal pyramid of sides (35 mm) and height 65 mm is resting on HP on its base with the two of the base sides perpendicular to VP. The pyramid is cut by a plane inclined at 30 degrees to HP and perpendicular to VP and is intersecting the axis at 30 mm above the base. Draw the development of the remaining portion of the pyramid. Okay, we'll continue with the next problem. A hexagonal pyramid of sides 35 mm and height 65 mm is resting on HP on its base with the two of its base sides perpendicular to VP. That's the condition. So with the condition, this is the two of its sides perpendicular to VP. I have written the top view. The pyramid is cut by a plane inclined at 30 degrees to HP and perpendicular to VP. 30 degrees to HP and perpendicular to VP. This is the section plane. And is intersecting the axis at 30 mm above the base, which is intersecting this axis at 30 mm above the base. From the base 30 mm axis, so from this point you need to introduce a section plane 30 degrees to HP and perpendicular to VP. Draw the development of the remaining portion of the pyramid. So you need to draw the development of the remaining portion. So to draw the development of the remaining portion, you just have a look at the front view. So this is the front view. I am not going to take much time on the front view because you are already familiar with the front view, writing of the front view. This is as same as the projection of solids. Okay, so I need to name the edges. I am going to take this as A, B, C, D, E and F. So here this is O dash, this is O1 dash, this is A dash in bracket F dash, this is C dash in bracket D dash, and this is B dash in bracket E dash. Okay, and this is the retained portion. This is the retained portion. Retained portion. And since here edge is overlapping with the axis, you should represent the edge, not the axis. When the edge is overlapping with the axis, you need to represent the edge, not the axis. So this is the retained portion. Now we need to construct the development. To construct the development, you should keep in mind always development, all the lines should be in its true length. Okay. So here just have a look at the top view. Is any lines parallel here, appears parallel to XY line here? Any line? Say for example OA, is it parallel to XY line? No, it is not parallel. OB, it is not parallel to XY line. OC, it is not parallel to XY line. OD, not parallel to XY line. OE, not parallel to XY line. OF, not parallel to XY line. None of the lateral edges OA, OB, OC, OD, OE, OF is parallel to XY line. So none of the edges in the front view, that is OA, OF, OB, OE, OC, OD is in its true length. Okay. So you cannot take the points directly from here and measure to construct the development. You need to identify the true length now. Okay. So to identify the true length, again we need to go back to the concepts of projection of lines. If a line appears parallel in one of the plane, you will get the true length of that in the other view. So you need to make one of the line parallel by rotating. That is the concept of line. You need to rotate one of the line, you need to make it parallel. From that point you need to project, and then from that point you need to get the true length. That is what the concept of lines we have learnt in the case of lines, projection of lines. So now we will take up OC. I will just draw a horizontal line. I will just draw a horizontal line for the reference. I will take up OC. I will going to rotate this OC. I will make it parallel here. OC. This is C1. I will name it as C1. So OC1 is appearing parallel. OC1 is appearing parallel. I am rotating OC to make this parallel. OC1 is appearing parallel. From C1, I am going to take the projector from C1. So this point is C1 dash. Join O1 C1. Join O1 C1. Join O1 C1. If you join O1 C1, that will give you the true length. Okay, O1 C1 will give you the true length of the edge OC. Now identify all the points where the section plane cuts the lateral edges O, A is cut by section plane at this particular point, 1 dash, OB 2 dash, OC 3 dash, OC, OD again that particular point only, which is 4 dash in bracket, OE 5 dash in bracket, OF 6 dash in bracket. Since it is hexagon, you will find 6 different edges. So section plane cuts the 6 different edges at the points 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Okay. Now none of the points are on the edge which is true length. Therefore, you just extend these points to the true length line, which is OC1 dash. Extend O dash 1 dash 6 dash to the OC1 dash, 2 dash 5 dash to the OC1 dash, 3 dash to the OC1 dash. So this is new 1 dash 6 dash, this is new 2 dash 5 dash, this is new 3 dash 4 dash, which is on the true length line. So you need to measure these distances to draw the development, which will be the true length, which will give you the true length. Now the development part is as similar as the pentagon, what we have taken up in the previous problem. So select any random line like this, that should be in its true length, O1 C1 dash. Okay, this is O1, this is C1 dash. This should be in its true length, where this is the true length. Okay, so if you construct to the scale, the true length comes to 73.8. So true length is equal to 73.8. You'll come across 73.8. Now just draw curve using this as center, this as radius. Draw curve. Now this has got 6 edges, A to B, B to C, C to D, D to E, E to F, F to A. So 6 edges having equal sides, 35, 35, 35, 35, 35, 35. Therefore measure 35 in your compass, select this as center, 35, cut an arc. Similarly 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 35, cut an arc. How much? 6. 1, 2, 3, 4, 5. One more. 6. Join these two. Now try to join all the construction lines here, all the divisions with 35. Now this should be 35. This should be in its true length. This is all the 6 lines. 1, 2, 3, 4, 5, 6 represents the 6 lateral surface of the pyramid. Now try to measure the length O dash to 1 dash, O dash to 1 dash should be on O dash to 1 dash, O dash to 1 dash. This is 1 dash. This is A, B, C, D, E, F, A. So the same distance you need to measure here. 1 dash. Similarly, the same distance 6 dash to F dash. To F dash. F dash, where is F dash? Here it is F dash. 6 dash. Similarly, O1, 3, 1 and 4, 1 for the edge, 3, 1, 4, 1 for C and D. O1, 3, 1, 3 dash, 4 dash. O1, 3 dash, 4 dash. C. This is 3 dash, 4 dash. Similarly, O 2 dash 5 dash. 2 dash 5 dash is for the edge B dash E dash. 2 5. This one. This distance 2 5 here. 2 dash 5 dash. Now you need to join all these lines to get the development. 1 dash to 2 dash, 2 dash to 3 dash, 3 dash to 4, 4 to 5, 5 to 6, 6 to 1, 1 to A. Now here 1 to A. Again, since it has got edges, 6 edges, you should join A to B with the straight line. If it is cone, then you should leave it as curve. If it is having edges, you need to join it by straight lines. C to D, D to E, E to F and F to A straight lines. Again, the development is not completed yet. You need to join all the retained portion of the lateral edge, that is 2-B, 2-B. Only this is the retained portion. This is cutoff portion. Similarly, 3-C. Only this is the retained portion. This is cutoff. 4 to D, 5 to E, 6 to F. So this is the development of said problem hexagonal pyramid. So this is the development of lateral surfaces session. I thank you very much.